Hi and welcome Pure Maths 3 students to week 12 of our maintenance course, where we are investigating, going over topics that we've already covered in class just to keep them fresh in our minds. First one is an algebra question. This is, I think they're all past exam questions today, I think. So this one here, we've got the polynomial ax cubed plus bx squared plus x plus 3, and we know that a and b are constants, and it's denoted by px. And we know that this is a factor, so 3x plus 1 is a factor, and that when we divide px by this, we get a remainder 21. So we've got to find the values of a and b, and this will be using, of course, a simultaneous equation. So if 3x plus 1 is a factor, that means that p minus 1/3 is equal to 0. So we just plug that into our equation. So we get a minus 1/3 all cubed plus b into minus 1/3 all squared, and then minus 1/3 plus 3 ought to equal 0. So my next line will be minus 1 over 27 plus 1/9. So that's a, this is a, this is b. Minus, okay, and I guess we could write that as 8/3 plus 8/3. And perhaps we could just multiply everything out at this point by 27. So if I multiply it out by 27, I get negative a plus 3b plus 72. Oh, I should have an equals 0 here. And so I could say that a is equal to 3b plus 72. That's my first equation. Now, I know that p2 is equal to 21, given that there's a remainder when I have a factor of x minus 2 of 21. So p2 is 21. So all I need to do now is go, well, insert x is 2 into this. So I get 8a, because 2 cubed is 8, plus 4b, because 2 squared is 4. Plus 2 plus 3 equals 21. And so we get 8a plus 4b equals 16. And divide everything by 4, so we get 2a plus b equals 4. And now I can substitute in what I found a to be. So I can go 2 bracket 3b plus 72 plus b equals 4. So I get 6b plus 144 plus b equals 4. And so 7b is equal to negative 140, which means that b is equal to negative 20. And therefore, I can substitute the negative 20 in to find out what a is using this one here. Negative 60 plus 72, so a is equal to 12. All right. That's our algebra question for the day. The logarithmic and exponential functions question requires us to solve this to 3 decimal places using logarithms. So I'm going to take a natural log of both sides. So when I do that, that gets rid of the e on the left-hand side to give me ln 3 to the x minus 2. And then I can rewrite that, and my next line is x is equal to x ln 3 minus 2 ln 3. And I'm going to bring my x's over to the left-hand side. So I should have this as my next line. Then I'm going to factorize out, so I get 1 minus ln 3 as in a bracket equals 2. What am I doing here? Sorry, guys. That should be ln. My brain is not functioning super well. 2 ln 3, and then 2 ln 3 and 2 ln 3. Okay, now I can get x by itself by going x is equal to negative 2 ln 3 all over 1 minus ln 3. And then when I plug that into the calculator, I'm getting 22.281 to 3 decimal places. The next one is a trigonometry question, and for this one what I'm going to do is I'm going to use my addition rule first. So I can, so my sine addition rule will be sine 2 theta cos theta plus cos 2 theta sine theta. And now I'm going to use the double angle rule at this point for sine. So this will be, it'll be 2 sine theta cos theta, like that. But I've also got this cos theta here, so another cos theta there. Then I'm going to use the double angle rule for my cosine 2 theta. Now, there's 3 different options here, but you can see that I'm needing these sines here, the sine cubed. So what I'm going to do is use the 1 minus 2 sine squared theta version of the rule. So I'm going to go sine theta, and then this bit here is going to be 1 minus 2 sine squared theta. Now, this is in your formula sheet, so I would even just print your formula sheet out so that you can just have these and cut these out so that you can just follow them around. Let me see, here we go. I've got them here. Okay, so you can see what I've just used here. I've used that one, so that's this bit here. And then now I'm using the cos 2a equals that one there. So this is this bit here. Okay, now this can simplify to 2 sine theta cosine squared theta plus sine theta minus 2 sine squared theta, cubed theta, actually. Now I'm going to change this cosine squared theta here. I'm going to change that into 1 minus sine squared theta. So I go 2 sine theta into 1 minus sine squared theta using my pure maths 1 rule. So I get that. Now let's just get rid of this. So running out of room, I'm going to go over here. I expand that bracket so I get 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta, and then that means if we gather our like terms, we will get 3 sine theta minus 4 sine cubed theta, which is exactly what we want. The next question is a parametric equations differentiation question. So what we want to do here is we want to find dx dt, and then we want to find dy dt. So ultimately we know that dy dx is going to be equal to dy dt by dt dx. Okay, but first we want to differentiate each of these. So let's do dx dt. Now what I'm going to do is I'm going to say that u equals cosine t, so du dt is equal to negative sine t, and I'll say y is equal to u to the negative 3, right, because it's cosine cube, it's 1 over cosine cube theta, t, and therefore dy du is going to be negative 3 u to the negative 4, or another way of writing that is negative 3 cosine to the negative 4t. And therefore we can now put that all together using the chain rule that we've just done. Dx dt is equal to this multiplied by this. So we should get sine t of positive 3 sine t, sorry. Let me just move that over a bit. Can I move that? No, I can't. Whoops, not like that. Let me just delete this here. It'll be 3 sine t over cosine to the 4t. So that's that one. Now we're going to do dy dt, so we're working with this. So we're going to say u is equal to tan t. And so du dt is equal to sec squared t using our rule. It's on our formula sheet. And then y is equal to u cubed. So dy du is equal to 3u squared, which is equal to 3 tan squared t. And we can put that together. Dy dt is equal to, we multiply that by that, which is 3, and we can say sine squared t over cosine squared t multiplied by, now sec squared t is like 1 over cosine squared t. So altogether we get 3 sine squared t over cosine to the power of 4t. Now, we go back to this bit here. So if we want to find dy dx, so we go dy dx is equal to dy dt. Now that's this bit here. 3 sine t squared t over cosine to the power of 4t multiplied by dt dx. Now this is dx dt, so dt dx is the reciprocal of that. So we get cosine to the power of 4t all over 3 sine t. Now you can see some cancelling is in order. That sine t cancels out one of those. That cancels out all of those. And so we get is equal to sine t, which is what we needed to prove it from the beginning. So that's good. Now it says, hence show that the equation of the tangent to the curve at the point with parameter t is this. Now this is a straight line graph. So we know that the gradient, this is the gradient here, isn't it? Right, dy dx, right? So we know that we've got a y equals sine tx plus c type graph function. And we can therefore put in the x and y values. So how are we going to do that? If these parametric equations up the top here give us x and y, we can chuck in our y values. So we just go tan cubed t is equal to sine tx. Now x we can say is equal to 1 over cosine cubed t plus c, and then we can rearrange for c. So we get, let's make it that tan cubed t is sine cubed t over cosine cubed t, take away sine t over cosine cubed t equals c. And then we can factorize that perhaps, so we go sine t over cosine t into sine squared t over cosine squared t minus 1 over cosine squared t. And this gives us tan, now, gee, I'm running out of room here, aren't I? And that's, sorry, and this is still what is equal to c. And we can say that's tan t into tan squared t minus sec squared t. Now, if you look at your formula sheet, this bit here is equal to 1, so you get tan t equals c. And therefore now, this is a bit of a nasty one, isn't it? Now we can write the equation. So y is equal to sine tx plus tan t. And we're done. Because that's what c is equal to. Okay, so the next one is an integration question. And we've got to integrate this ln 2x and show this here. So the first thing is you can't integrate ln 2x just like that. You need to integrate by parts. So what we would do, and this is in the integration by parts section of your textbook, So you might want to look at an example of this. But what I'm going to say is that when I integrate ln, it's like integrating 1 times ln 2x. And that's equal to uv, which I'm going to, like this, minus the integral of x times 1 over x. Now you might be thinking, what the blazes is he doing? So here we go. Remember your product, your integration by parts rule is integral of u dv dx is equal to vu minus integral of v du dx. Okay, now, so what we're going to take is we're going to say that u is this, and we're going to say dv dx is this 1. And the reason we do this is because otherwise we can't differentiate ln x, so that's why we've done this. So go back to that part of the chapter and see why we do this for a more detailed explanation. Okay, now if that's the case, if 1 is dv dx, that means that v is x. Okay? And u carries on, right? So that's there, that's there. And du dx is going to be, so du dx, this bit here, is when we differentiate the ln x. So that's, and that x is the v. Okay, so that's what we're going to do. We're going to work with this side here. So here we go. X ln 2x, and then I'm going to differentiate this. So that's x over x, which is just 1. So when I integrate x over x is 1, integrate 1, and I get x. And I'm doing this between 1 and a. So I'll put that there and that there, and then I can rewrite that as a ln 2a minus a minus, and then I insert 1 ln 2 times 1, so ln 2 minus 1. Oh, and this is all meant to equal 1, right? So I should have equals 1 equals 1. Now I'm trying to get to this here. Let's see how we can do this. So my next line will be a ln 2a minus ln 2 plus 1 equals 1. Now I'm going to go a ln 2a minus a. I want to bring the other things across the other side. Well, the 1 will cancel out the other one on the right hand side, so I'll be just left with ln 2. This is looking positive. Now I'm going to factorize out that a. And then I can divide by a, so I get ln 2a minus 1 equals ln 2 over a. Then I can add the 1. Yeah, look, I'm getting real close now. 1 plus ln 2 over a. Now I'm going to take the exponential function of both sides, which will get rid of the ln on the left-hand side and leave me with e to the power of 1 plus ln 2 over a on the right-hand side. And then at this point, I'm going to get, I can divide both sides by a, so I get a equals e to the 1/2, I guess, or e to the 1 plus ln 2 over a. Okay, so that's that question. So the last question, I think this is the last one. I've got to use the iterative formula, that's the one that I just found in the previous question, to determine the value determine the value of a. Oh, that should be a, corrected 2 decimal places. Okay, I should be given some kind of starting point here. A is greater than 1. usually they'll give you some kind of idea of where the root is. I wonder if I just didn't give enough, bring enough information over from the exam. Well, I'm going to try a equals 1, 0.5. So a1 equals 1.5, and let's see where we get to. So 1.5, I pop that in my calculator as my answer. Then I'm going to use this formula. So I'm going to type 1/2 e to the power of 1 plus, and then we're going to put ln2 all over, and then we go answer, and then I get, as my second value, I get a2 equals 2.1575, a3 equals 1.8741, a4 equals 1.9674, a5 equals 1.9332, a6 equals 1.9453, a7 equals 1.9409, oops, that's a 9, a8 equals 1.9425, a9 equals 1.9419, a10 equals 1.9421, a11 equals 1.9421, a12 equals 1.9421, a13, I think we're there, equals 1.9421. Okay, so at this point we're going to say a is equal to 1.94 to 2 decimal places. And that is it for this week. Well, I hope that's been helpful. There's a few tricky ones in there. This question here, I think, may have had a little bit more information, like knowing that we needed to start near 1. Or, well, it did say a is greater than 1 up here. So, but yeah. All right, hope that's been helpful, team. God bless.